So quite a few of you guys in the comment section have been asking me how I create my images for my videos, my thumbnails, and my posts on my YouTube videos. So let's jump right into it in this video. The primary system I use for my workflow for images is Stable Diffusion, which is an open source AI image generator that has been out for quite a while, since August 2022. So if you don't know what Stable Diffusion is, you must be living under a rock. Personally, I use Stable Diffusion in a local environment. My computer's specifications are as follows. So if you wish to install Stable Diffusion locally, the first and foremost thing you need to consider is whether or not your GPU can take it. For me, I have an NVIDIA graphics card of RTX 3070 Ti with 8 gigs of VRAM, so Stable Diffusion can run for me just fine. So if you have a PC or a gaming laptop that runs the 300 or 400 series, it shouldn't be a problem. If you are running on the Windows environment, you need to install the following to clone the necessary files onto your local environment. On top of that, you also need to download Python 3.10.6 to run Stable Diffusion because it runs on Python code as well. You could try installing other versions of Python as well, but some of the extensions aren't compatible with newer Python versions. Once you have all those installed onto your local environment, just follow the following instructions on the web page so that you can get started with Stable Diffusion. If you turn your attention to the top left hand corner of the user interface, you can see that's where you use the primary Stable Diffusion checkpoint. For me, I personally use Anyverse version 12, Minamix, AnyLoRa, and Epic Realism for some of my pictures. On top of that, I use character-specific LoRa's, which I did a tutorial on a while back, so you can check the video out as well. Most of these things I found on Civid.ai, but you can also check out Hugging Face to see if there are any models that you find interesting and you want to use for your workflow. And to install those checkpoints onto your local environment, you just have to go to the file where Stable Diffusion is installed, go to Models, and place the Stable Diffusion checkpoints under the folder Stable Diffusion. For the LoRa's, you will place them under LoRa. To double check whether they are installed onto your local environment, just press the refresh button and see the drop down on the screen to see whether it's right there. And for the LoRa's, just click LoRa and it should be there under the tab. On the web UI user, there are two primary functions you can use to create your images: text to image and image to image. So it's pretty self-explanatory. Text to image is where you input a text and the AI creates the image from the description from scratch. Image to image, on the other hand, you provide it with an initial image and a text prompt as well, and you can see what it generates. So let's jump right into text to image first. As you can see, there are two boxes here that you can input your prompts. First off is the prompt and the negative prompt. So the prompt is a description of the image that you want to generate, and the negative prompt is, of course, the things that you do want to appear on your image. You can use some quick textual inversions to make things easier for you. Those are also available on Civid.ai, so I use things like bad hands, cyber realistic negative, or fast negative. I'm just gonna plug the textual inversion prompts right in, so bad hands, fast negative, cyber realistic negative. You also need to separate them with commas so that the AI can break it down much easier. And we're gonna use the Kotor LoRa that I trained in the previous video a while back. So as you can see, the text here, it's LoRa Kotor V2 1. So the numerical value here, this is the weight of the LoRa. So I normally run it around 0.8, so it controls how much the LoRa influences the picture. So things like 0.1, 0.2, you will virtually not see anything. So I would normally keep it around 0.8, 0.9. And if you're running multiple LoRa's at the same time, you just have to play with the values accordingly and see what the image you get produced. So since this is an Anyverse, which is trained on photorealistic anime pictures, so we're just going to try it right here. One girl, upper body portrait, smiling, looking at viewer, beach background. Okay, so this is the prompts that we will try to use. So for me, or for normally, the sampling method that you will use is dpm++ 2m keras. So for sampling steps, you want to increase this value if your prompts are much more complex, if there are much more things that you want to write onto these things, so that it will have more time to, the AI will have more time to generate the details required. We're just going to stick with this 1:1 ratio, where it's 512 by 512 pixels, and we're just going to stick to the CFG scale, which is essentially how closely the AI generates your image to the prompt that you give it. So let's go ahead and generate the picture. As you can see here, it's just a random picture of a random girl, because that is because I didn't add in the activation word. So let's put it right in, DAZZLING. So I'm just going to put it right in, DAZZLING, which is the activation word that I used to train this model. So let's go ahead and run it. As you can see, yes, DAZZLING is right here, smiling in the beach with blue eyes and a lovely smile. Yes, so this is just basically how text to image works. So if you want to change things up a bit, if you want to change the aspect ratio, you can also try it. So for instance, if we go for a 2:3 ratio, which is 512 to 768 pixels, and we just generate that, you'll have a wider view of the character actually. So you just play around with these values and see what works best for you. So as you can see here, compared to the first picture, she has longer hair right here. If you wish to change some details of the picture but still want to keep the picture the same, you could click this button right here to retain seed, which is 861299789, and you can just add it right here in like maybe short hair, and then there you go, you run it. And the long hair just disappears. I mean, it's not like DAZZLING, she needs to have like the things at the side and the hair bun as well. So this is just like DAZZLING with short hair but wearing the ropes thing. So in addition to using descriptions of the character of the background, you could also throw in some photography terms to change up the angle a bit and make it look more dynamic in a sense. So I've been using upper body for most of my pictures, but if you want to add a certain tilt to it, you could use things like you could use prompts like dynamic angle or Dutch angle. And you can see that there's a certain tilt to the picture now. Other terminologies that you can throw in are, if you want to have a more full body image, of course, the direct prompt is just a full body image. Though I've noticed that some models have the tendency to produce mostly portraits as a whole. But there you go, there's a full body portrait of DAZZLING. Though you may need to increase the resolution a bit for some of these pictures because they may mess up the faces a bit, or you may need to inpaint or edit the photos accordingly afterwards. And if you want the in-between upper body and full body, it's called a cowboy shot. So it's more or less from the top of the person to the waist level or slightly below the thighs. That's what a cowboy shot is called. So there are many other things that you can throw in as well for their photography terms, perhaps even a lighting, say bokeh, just keeping the prompts the same. We throw in the term bokeh. and there's just a slight difference in the lighting from the previous picture. About landscape images. So the normal aspect ratio I will use for landscape images is 3:4, which is 768 pixels to 1024 pixels. Oh yeah, I completely forgot to flip it over, but this is an easy tool for you to use if you want to switch up aspect ratio from landscape to portrait. So the width, it will be 1024 pixels, and the height will be 768 pixels. So we're just going to run that. And interestingly, if you notice, the picture now produces two characters in the same picture, which is not really what you want sometimes. So another small prompt that you need to throw in is the word solo, and perhaps even throwing in duo into the negative prompt. And there you have it, a photo of Bastila in all her glory at the beach. And since we are mostly done with text to image and prompt engineering, I think we shall move on to image to image. So what I'll do actually normally is I'll combine certain pictures that are found on the internet. So for instance, I have this image of Princess Leia and Darren Shan, and as you can see right here, they really do not look like the same. They're in the same universe, because like one has like these eyes and the other one has like another kind of thing. So what we do here, okay, I'm going to change this to the same sampler that it was, and we're just going to change it to resize by. So you must take note of the values of the pixels. Sometimes it may be a bit too off. And the noisy strength is actually for image to image, is how much noise you add to the image before it generates back, or it tries to generate stuff. Because stable diffusion works in a way whereby it adds a lot of noise to the picture, and then it tries to replicate the picture based on the text prompt you give it. So I'll normally set it about 0.6, 0.5 if I don't want to change the picture too much. We're just going to leave the prompts and the text prompts blank, because what we're going to do is we're going to use ControlNet, which is a way to control what the AI does, or like segment out it properly so you won't have problems. So what I like to use is using Lineart Realistic and a Control V11P SD15 Lineart SP16 as the model. And we're just going to drop right in and just wait for it to load. So this will probably take about a minute to do so, given the current resolution of 128 by 720. And as you can see, the style is somewhat more even. She still looks a bit Caucasian with the style, but that is the pre-processed image, so you can see it finds the outlines and the bounds of the images, and it just tries to replicate it accordingly. So the color gradient is roughly the same now, and it's not so oddballish-ish. And then I'll feed the image into Photoshop. I'll try to adjust the coloring accordingly and see how it goes from there, and then I'll use it as the thumbnail as well. And perhaps some of you guys have also been wondering how I created those Clone Wars style images. Well, I also use ControlNet for that. So for example, here we have Lana Beniko, and I have the following prompt using my LoRa, which I trained on the 2003 Clone Wars art style, and we just have the basic prompts, the basic description of her. So one girl, the Clone Wars 2003 style, short blonde hair, yellow eyes. We could probably add some things in like armor, neck scarf, because well, there's a neck scarf right here. Based on the size, I think there shouldn't be a problem, so we just click it to denoising strength. And the ControlNet module that I'll normally use for this, when it's just changing art styles of a particular character, is Open Pose. So open pose basically looks for the eyes, looks for the nose, looks for the face. So like it finds a border between, like, you know, the head, the chin, the mouth, the nose, the eyes, and sometimes even like the body and the shoulders, and then it interpolates accordingly, and the stable diffusion will generate the image based upon the ControlNet settings. So we're just going to throw it right in, and we're just going to try it out. Okay, this looks kind of messed up. But yeah, you can see that it creates the bounce. So this is the mouth, nose, eyes, head orientation, eyebrows, and the contour of the face. And it produces this image of Lana the Nico, though it's kind of cursed and she looks really sad in a way. So all these minor details, we could fix it using Inpainting as well. So I'm just going to send it into Inpainting right over here. In the Inpaint module, we draw over the unnecessary details, which are these particular lines right here on the AI generated picture. So AI has a tendency to draw these extra lines, and yeah, I just don't get it sometimes. And what we're going to do is we're going to use the following settings. Inpaint mask. So there are 4 options here: fill, original, latent noise, latent nothing. So fill is just essentially blurring out. What you do is you blur out these sections that you have inpainted, and then after that they will try to restore it accordingly. With the pixel size, it should be the same, so there's no problem. The denoising strength on the other hand, since we're trying to actively erase it, we will just increase it to 0.8, and ControlNet should be disabled for this particular step because it is unnecessary. Yep, so it cleared up the chin a bit, but it looks like it added a bunch of extra details for the top part. So let's just try it again. Just to erase this section right here. Good, so it's more or less even, and yeah, the details are fixed. So there we go. Inpaint is quite useful for some details that you want to erase in the pictures, especially if, like, you know, with AI art, with AI imagery, it does produce extra fingers, distorted arms, extra details that you may not want. So Inpainting is the way to go most of the time. Well, that about sums up my entire workflow of how I use Stable Diffusion. I hope this was useful for you guys, and I don't know, let me know what else you want to see in the future. As always, if you're interested in more Star Wars content or KOTOR related content, do drop a like and subscribe. Thanks for watching, and may the Force be with you.